All right, so this is the first question from your exam review, right?
Mm-hmm.
Okay. So I'm gonna do the first one with substitution and the second one with elimination, and then we'll just look. Okay, so the first one's set up for you nicely, right? So sometimes like the questions won't be set up where one of the variables is already isolated. See how this one isn't?
Mm-hmm.
So this one's just kind of setting you up to use substitution because it's y equals x plus 3, right?
Yeah.
So let's for a second, this is the way I taught it, and I don't know if like how strong you are with it, I don't know. But let's just say for a second that y's can be represented with blue boxes. Do you see another y anywhere on the page?
Yeah, 2y.
2y. So I'm just gonna scratch out the y, the another blue box, right? Now you can just, what is a blue box equal to?
X plus 3.
Okay, so why don't you replace the blue box in the second one? Remember what I said with you?
Yes.
Where I numbered the two equations, 1 and 2. So replace the blue box in number 2 with what the blue box is equal to in number 1. Does that make sense?
Yeah.
So I'm simply like, I'm not going to see a blue box anymore. I'm going to see only things with X in them. Does that make sense?
Yeah.
So I basically am going to substitute the blue box in, right? So I'm going to get 3x plus 2, and there's the blue box. Get rid of it. It now becomes x plus 3
Equals negative 4.
equals negative 4. Does that make sense?
Yeah.
So now you can, I only see x's there now, right?
Mm-hmm.
So now you can just solve for x. So I'm going to distribute this in, the 2. Then you get 3x plus 2x plus 6 is equal to negative 4. Right? Now I can collect like terms. Yeah, catch up.
Yeah, so no. 3x plus 2x plus 5. That?
Yeah, where's the 5 from?
2
2 times.
Oh, times.
Sorry.
Thank you.
Close. Okay.
Yes.
Now I see, you can do this one of two ways. You can, I would move the 6 over. So I do negative 4 minus 6,
Okay.
right? And then, what are you going to get? Right, so I'm gonna physically take this. I'm going to subtract 6 from both sides, or move it over. I'm going to get 3x plus 2x is equal to negative 4 minus 6. Now I can just collect like terms.
Yes.
And just add up both sides, right? Because everything's separated.
So 5x is equal to 10. Negative 10.
Good. Negative is important. So then I can divide both sides by 5.
Of course.
And x is going to equal negative 2. Right?
Yeah.
Now, once you have that, I'm just going to go back up here. I'm going to get rid of my little blue boxes. And lo and behold, there's some y's underneath. So now you can solve for what y is, right?
Yeah.
So, which one do you want to pick? I want to pick the easier of the two, right? So the one that already says y equals.
Yeah.
So if I know that x is equal to negative 2, then I'm going to plug it into number 1 where it says x. Does that make sense?
Yeah.
So y equals
Negative 2
negative.
plus 3.
Yeah, true. Good. Negative 2
So y equals 1.
plus 3. So y equals 1. Now, there's one more step. And don't forget this, or I dock you marks.
Okay.
It says solve the system of equations. Solve simply means state the POI, or the point of intersection. Right, so that's where the two lines are going to cross. The point of intersection is the solution. Right? So then my POI is negative 2, 1. That's where the lines are going to cross, is at negative 2 and 1.
Hold on a second. Okay, so the point of intersection is negative 2 and 1.
Yep. So that's where the two lines are crossing, right, on the graph. That's it, right? And then, do you want to do B? We can do B now.
This is so.
Okay, so here's B. Okay, and for B, I'm going to choose to use the elimination so you get both of them, right? Also, for reasons that you may or may not know, B is also kind of set up a little bit more in favor of elimination.
Yeah, because you have to do this, you would have to just times all this by 3.
Oh, good.
I know elimination
Good.
kind of well.
Okay, good. So you're going to, again, I would number these 1 and 2. And then on my side, like, I would say, okay, well, I try and, like, make it so that the teacher knows that I know what I'm doing, right? So I'd say I'm going to multiply, my step underneath here is going to be multiply equation 1 by 3, right?
Yeah.
And then I kind of get a new equation, right? It's call that a scalar multiple. It's just 3 times bigger, right? But I like to write it as a new equation, keep myself organized. So I label it 3, right? And so it's going to be, if I multiply the first one by 3, it's going to become 9a plus 3b is equal to 15, right?
Yeah.
You good?
I'm almost.
Almost there? Okay.
Like that? Wait, no, write it.
You could which one did you multiply? Did you multiply the second one or the first one?
The second one.
Oh. Why'd you choose
times 3b. Oh, okay.
Why'd you choose the second one? Is my question.
I don't know. Actually, no, you could do the top one, so.
Yeah.
Okay, sorry, so I'll just.
That's okay. And this is the preferred method amongst most students,
Yeah.
right? It's a little bit, not that substitution is subjective, but it's a little bit hard to see sometimes.
Yeah,
right?
it is.
Because to conceptually see. This way is a little bit more methodical, right? You can kind of, multiply by 3, and then we'll see in a sec what we do next, but there's steps.
And then we knock out b.
Okay, good. Okay, so good. So I always do, and then I'd write the second equation back underneath. So I'd go 2a plus 3b equals -6, right? And then I'd say on the side or something, or wherever, I'd say subtract equation 2 from 3, right? So I can throw a little minus sign on there.
All right.
Right? And keep in mind, okay, so this, when you do this, you look at this like you're going to do 9a minus 2a, right? 9a minus 2a.
Mm-hmm.
And then you're going to go 3b minus 3b. And then you're going to go 15 minus -6, right? Each one has to be subtracted, right? Don't skip any step. You know what I'm saying?
Yeah.
So don't think, oh, it's already minus here. I'm going to do 15 minus 6. It's not 15 minus 6, 15 minus -6, okay? So you're actually adding. That's a big change in the question, right? So then I'm going to go, okay, well, 7a plus 0b's, because they canceled out.
Yeah.
3 minus 3 is 0, is equal to 15 minus -6. Well, that's 21. So 7a is equal to 21.
Divide by 7.
Exactly.
A equals 3.
A equals 3. And then you can take that and do what with it?
Plug it into one of your equations.
It could be number 1, 2, or 3. You go find the easiest one that looks like that you can do in your head quick. Least.
I'd pick 2.
You pick 2? Mm-hmm. I'd pick 1.
Oh, okay.
Right? Because I can do 3 times 3. That's 9. Right? 9 plus b equal to 5. I can isolate it out a little bit quick, easier. It's less work. You don't want to do any work, right?
Yeah.
Like all the hard work's done. Once you get a variable, the hard work's done. And then you don't want to do anything more difficult. You just find whatever's the gonna give you the answer the fastest, right?
B equals -4.
I don't know yet, but that sounds about right. So 9 plus b equals 5. 5 minus 9 equals b, so -4 equals b. And then are you done?
No.
POI is?
Point of intersection.
And this one, okay, here's a little subjective.
Okay.
And this isn't an official rule, it's just a rule that I kind of follow. What comes first, X or Y?
X.
Right. So I always kind of label these things. When I do my point of intersection, I always kind of go A, B.
Oh, okay.
And that could change depending on what's on the axes, but you're not provided with anything here, right? So, you know, so if it was time and height, like a quadratic, then you'd put time on the X and height on the Y. You got to just conceptually think about it. So, but for arbitrary things like this, you can just go 3 and -4 because that's the order of the variable.